Now that you've worked with transformations of points for a couple of days, we're going to move on to parent functions. And what I'd like you to be able to do by the end of section 1.9 is to understand and explain what a parent function is, determine which parent function is used based on the graph or equation that you're given, identify transformations on parent functions. So before we go any further, let's just define what a parent function is. It's the simplest function with the defining characteristics of the family. When you're identifying family, I kind of want you to relate it back to families of people. So I have 2 children, and their names are listed below. So I've also listed some other names below. So just by looking at those names, circle the choices that you think are the names of my children. Well, if you guessed Scott and Danae, you are correct. And if I would ask you why you chose those names, you probably would say something like, oh, they had the same last name. And that is an identifier. Just like people, functions have identifying characteristics that group them into a family. So think of a parent function maybe as the last name of the family. So now I've listed some functions here below, and I would like you to identify the ones that are parent functions. Now when I say parent functions, they don't have any operations of addition, subtraction, multiplication, or division. They only have their last name. So if we look down here, the first one here, we can see that it's multiplied. We're multiplying by 2. So that's not going to be a parent function because of this. Nothing is added, subtracted, multiplied, or divided. Now, this is part of the last name. It's exponents and root symbols are part of the last name. Here, we're subtracting 3, so this is not a parent function because of this. Here, we're dividing by 3, so this is not a parent function because of the division by 3. This has nothing added, subtracted, multiplied, or divide. This one does not either. All right, now we have a table here, and I want you to be able to, by the end of section 1.9, be given a family and be able to identify what the graph looks like, what the name is, what the domain, what the range is, and where it intersects the y-axis. So these are the families that we're going to be working with in section 1.9. And we'll start out with the constant function. A constant function, the rule is f of x equals c. And you'll also need to know the rules for each function, and that's just the function notation for them. If we were to graph this, a constant function would just be a line. And we could put it across anywhere. It's going to be a horizontal line. So I'm just going to draw it across here. And then the domain, because this keeps going forever. Remember, domain represents what values x can be in that function. Since it keeps going on forever to positive and negative infinity, it would be all real numbers for the domain. Now, if we look at the range will be wherever it crosses the y-axis. So if it crosses up here, say at 5, it would be y equals 5. If it crosses down here at negative 3, then it would be y equals negative 3. So whatever the value is where it crosses the y-axis, because any point you pick on here is going to have the same y value. That's why y equals c. It's a constant function. It's going to intersect the graph, or its y-intercept, will be at 0, and then whatever our value is for y. For a linear function, that's a line, and it is going to go through the origin. And as you can see, also, it's going to keep on going to positive and negative infinity, so it's going to cover all along the x-axis. So the domain, and that's the same case for the range also, it's going to keep going. We could have a y that's 1,000, 10,000, a y that's negative 1,000, and so on. So the domain and the range are both real numbers. And the y-intercept is going to be 0, 0. Now for a quadratic function, linear should be able to remember what that graph looks like. Quadratic function, you should be able to remember that. You did that a lot in Algebra 1, but sometimes I tell students, think of the second letter in quadratic. That looks like kind of the shape of the graph. So the rule for a quadratic function is f of x, and that's the parent function, f of x equals x squared. And we're just going to sketch it in here. It's going to cross the y-axis, or that y-intercept is going to be here. And then we'll just make that look like a U, just kind of a smooth curve there. And the domain is going to keep going in both directions for the x, so that's going to be all real numbers. But the range, the smallest number we have for y is 0, so it's going to be y is greater than or equal to 0. And the y-intercept, or where it intersects the y-axis, is at 0, 0. The next function that we have, parent function, is the cubic function, and that is f of x equals x cubed. And it is also going to have a point at 0, 0, but it's going to kind of come up like this, take a little bend there. And so again, this is going to keep not as quickly as a quadratic, but it's still going to travel along the x-axis. So our domain is all real numbers, and it's going to go on forever in the negative y direction and forever in the positive y direction. So the domain and the range are both all real numbers. It's going to intersect the y-axis at 0, 0. And then the last one we're going to look at is the square root function. So the square root function looks like this, and sometimes I tell students, if you want to remember the square root function, kind of think of the symbol here. If you take the square root symbol and kind of round it, that's what the graph of a square root function looks like. And because we are not dealing with negative numbers yet, we're just in the real number system, we can't have any values for x underneath that square root sign that are negative. So it's going to start like this and kind of go like that. So you can see the domain is everything that's greater than or equal to 0. So x is greater than or equal to 0, and for the parent function, y is greater than or equal to 0 as well. It is going to intersect the y-axis at 0, 0. So if you're looking at this table, I filled in anything that was real numbers here, and I didn't fill in the ones, I did not fill the ones in that were different. Here, everything except the constant intersects the y-axis at 0, 0. And everything has a domain of all real numbers except for the square root. And two of the functions have a range of all real numbers. And then again, like I said, the ones that I didn't fill in were the exception to the all real numbers for the domain and the range. And that's going to be addressed on the next page. Just as a person's last name is an indication of the family that they belong to, the exponent or the radical sign indicates the family the function belongs to. So in section 1.9, you're going to be learning about families of functions, and I want you to remember that in order to be a function, the relation must pass the vertical line test. And if you notice in the table from the previous page, this is what I just mentioned. The domain is the same for all of the parent functions except for the square root. And all of the parent functions will always have a y-intercept of 0, 0 except for the constant, unless the constant function is y equals 0. So with transformations of functions, in section 1.8 you worked with transformations of points. If the operation was addition, the point moved left, right, or up or down. If the operation was multiplication, the point was stretched or compressed. And a negative sign represented a reflection. So all of those operations, make sure you understand what each one does to the function or to the points. In order to identify if a transformation was vertical or horizontal, you needed to look at the location of the transformation. So, for example, here the transformation happens with the y, so it represents a vertical transformation. So it's all about location, location, location. The same is true for transformations of functions. If the transformation is in with the x, and when I say in, I'm talking about inside the parentheses, the transformation is horizontal. If not, the transformation is vertical, and it can only be one or the other, of course, with one exception. And I'll let you know what that is. Given the parent function f of x equals x squared, I would like you to identify the transformations as horizontal or vertical below. So what we're going to do is we're going to look at each one. I want you to ask yourself if the transformation is applied to the x-coordinate. If not, it is applied to the y-coordinate. And like I said, with one exception here. So this plus 3 is not inside the parentheses with the x. So that means it's going to be so it's not horizontal because x is horizontal. That makes it vertical. The next one that we have, now this one could either be a horizontal because I don't have parentheses around here. It could be a horizontal transformation or a vertical one. And for this worksheet, we're just going to identify it as vertical since we're not putting any parentheses around that, but we will talk about that a little bit more. Here, it's happening, the transformation is happening inside the parentheses with the x. So inside with the x means that it is horizontal. And we have another one here that's inside with the x, so that is also horizontal. Okay, now one of the above transformations, either the vertical or horizontal, does not react the same way as it did with points. So let's see what happens when the pairs of functions are graphed on the same screen. So what I'm going to do is I'm going to show you a function, x squared, and that's the first one that I'm going to graph. That's going to be the first graph that appears. And then in the second graph that appears, I'm going to make it say x squared plus 3. So take a guess at how you think that's going to move. If you think it's going to be vertical or horizontal. Okay, so first one that graphs is going to be the parent function. So that's how we judge how it moves. So that's the first one. This is the second one. If you guessed that it was vertical and it was going to move up 3, then you were correct. So this one moved up 3. Now let's look and see what happens here. Now I'm going to change the graph, the second one, to read with parentheses x plus 5, and I'm going to square that whole thing. Now the transformation is taking place inside the parentheses, so that means it's horizontal. Again, the first one is going to be the parent function, so we're going to judge how it moves by the parent function. So here it is. Now, this said plus 5, but the graph moved left 5. So we put a plus 5 in here. Again, this is the original parent function. It moved left 5. So horizontal transformations with functions behave differently. So we're just going to put horizontal here. All right, so please be very careful with functions. Vertical transformations behave the same as they do with points. However, horizontal transformations are little stinkers that trip up several students, so be very, very careful. Reflections behave the same way as they did with points. If you take the opposite of the x-coordinate, the point reflects across the y-coordinate. And if you take the opposite of the y-coordinate, the point reflects across the x-axis. Well, we don't have points with functions. So with functions, you take the opposite of the x only, then you reflect across the y-axis. If you take the opposite of the y, which is in a function is represented by the entire side of the equation, you're going to reflect it across the x-axis. So remember, f of x can be thought of as y. So when you see this whole side represents y. So basically we're taking the opposite of y, so the function reflects across the x-axis, which is different than this. This is just the opposite of x. So if we're taking the opposite of x, we're going to reflect across the y-axis. All right, so let me give you some examples to look at, maybe to help you decide what you have here. Here we have x cubed plus 3. It's going to be vertical because we have that plus 3 out there. Not inside with the x, a vertical translation, and it's going to move up 3. This one, not inside the parentheses with the x, so we're going to call it a vertical, and because we're multiplying, it's a compression. Here we're adding, so it has to be a translation. Vertical compression by a factor of 1/2. Now, I said that there's an exception to this type of a problem. That could also represent a horizontal stretch by a factor of 2, and we'll talk about that a little bit more later. Here, the transformation is adding, so it has to be a translation, inside with the x, so it's a horizontal translation. It's going to the left, because what happens inside, I showed you, was actually what happened, went the opposite way of what you thought whenever it's an x. So that is going to be a horizontal translation to the left 4. Number 4, the negative sign is outside of the parentheses, so we're actually taking the opposite of the entire side, which means it's the y. And if we're taking the opposite of the y, it's going to, put this right in here, reflect over the x-axis. So opposite of y reflects over the x-axis. All right, see what you can do with the next page for your examples or your turn, and we'll talk about it tomorrow.